Welcome back to another explainer. Today, we are unpacking a really brilliant high school biology simulation called the Habitat. Now, at first glance, this looks like a pretty straightforward science lesson about, plants and soil. But as we're going to uncover today, it is actually a meticulously designed, high-stakes stress test of human psychology. Okay, let's dive into this.
Imagine you are the ecologist with a dying 2,400-acre preserve, and this number is your entire budget to save it. You've just been handed the keys to the Blackwater Nature Preserve, and you've got exactly 15 days to make your decisions. Every single action costs money, and absolutely every day counts. And right from day one, the visible problems are just overwhelming. You're staring down 5 completely distinct zones of ecological disaster. In Zone 1, you've got this incredibly dense invasive honeysuckle completely choking out the forest. Zone 2 is a wetland that's been totally taken over by phragmites. Then you look at Zone 3, the biggest one, that's 640 acres of former agricultural land with basically dead soil, zero biological activity. Add to that collapsing stream banks in Zone 4, plus some nasty urban stormwater and salt runoff in Zone 5, the stakes are massive right out of the gate.
Section 1. The complication. Delayed feedback.
So in most gains or simulations, you spend your resources and you get an immediate reward, right? A number goes up, a progress bar fills. But the Habitat introduces a totally brutal twist: ecological lag. We're talking about a solid 2 to 3 day delay between actually implementing a restoration action, like say planting native seeds or adding soil compost, and seeing any visible results in your dashboard metrics. And this delayed feedback drives students absolutely crazy, because naturally, seeds take time to germinate. Soil chemistry changes gradually. So these students will spend thousands of dollars and their dashboard will just sit there, completely flat, making them feel like they are totally failing.
Section 2. The real goal. Your brain.
Now, what's really interesting about this slide is that it reveals the whole thing is basically a Trojan horse. On the surface, the foreground is all about ecological restoration in biology. But the real destination is actually training what the creators call the 8 capacities for uncertainty, or the patience framework. So the biology is just the vehicle. This is actually a high-stakes stress test of cognitive psychology disguised as a video game. It's built to see exactly how the human brain processes uncertainty, high stakes, and of course, that awful delayed feedback.
Out of those 8 capacities, the absolute ultimate skill being trained, the signature capacity, is adaptive strategy. It's asking the question, can you revise your plan based on cold, hard evidence, rather than your emotional attachment to what you've already done? I mean, it sounds easy enough in theory, but when you're rapidly burning through a simulated budget and the dashboard just isn't moving, panic definitely sets in.
Section 3. 6 psychological traps.
To really force students to practice these capacities, the simulation literally weaponizes cognitive biases against them. The first trap they walk into is survivorship bias. See, on day 1, students read 3 glowing case studies of rapid restoration successes, like the famous Darby Plains project. So naturally, they base their expectations on these big wins. But ask yourself, what are those 3 successful case studies not showing you? Well, they leave out the 40% cost overruns. They completely omit the early failures in the invisible, agonizing years of soil preparation. By reading only about the rapid success stories, these planners are totally blinded to the reality of invisible failures.
And then, we run right into normalcy bias. Students are told the invasive species have hovered around 42% coverage for 3 years. So the brain takes a mental shortcut. It assumes that degraded state is perfectly stable. But nature is rarely stable. When the daily data starts showing a rapid acceleration in the invasive spread, students consistently fail to catch it. They assume tomorrow is going to look exactly like today, and they completely fail to navigate the uncertainty when the crisis actually starts accelerating. Then, on day 10, a simulated storm hits the preserve. It wipes out any unstabilized work. So imagine you've spent $40,000 and 5 entire days working on a wetland, and this storm just destroys it. Because of the endowment effect, students massively overvalue the effort they've already put in. Instead of stepping back and rationally pivoting to a different zone with a much better return on investment, they stubbornly throw good money after bad, just to justify their previous choices. It's a huge emotional regulation problem. And this brilliantly illustrates the zero-risk bias, what we can call the cost of perfection. Look at these options. Students can choose to spend $45,000 in 6 days to completely eliminate a threat in just one single zone. Or they can spend only $18,000 in 3 days to achieve an 80% reduction. That second option frees up $27,000 to go save the rest of the preserve. But our brains desperately crave that satisfying feeling of 100% elimination. Pursuing zero risk in one zone mathematically guarantees a mediocre preserve overall. It's a total failure of adaptive strategy.
Finally, we've got hindsight bias. At the end of the simulation, students finally see that investing in invisible soil health was actually the winning strategy all along. So suddenly they all start claiming, oh, I knew the soil was important all along. But there's a catch. Their mandatory Day 2 journal entries literally prove that they completely ignored the soil and prioritized the flashy plantings instead. It's brilliant. By forcing them to confront their own written journals, the simulation prevents them from rewriting their memories and forces a really honest, productive recovery from failure.
Section 4. Student Archetypes and Outcomes. When you subject people to this kind of psychological pressure, clear behavioral patterns emerge. The creators mapped the final dashboards and found that students fall into highly predictable archetypes based on how they handle uncertainty. And, spoiler alert, the boring strategy always wins. The soil builder archetype patiently invests in invisible soil biology. Their dashboard looks terrible for the first week, but they earn the highest overall scores. Contrast that with the flashy planter. They spend all their money making highly visible changes without building a biological foundation, which just results in dead seedlings and a totally wasted budget. And then there's the reactor, who just wildly chases whichever Gaily number looks the worst. They burn through resources with absolutely zero cumulative progress.
Section 5. Grading reasoning, not results.
This all leads to a complete paradigm shift in how the teacher actually evaluates the students. Because remember, this isn't a video game about getting a high score. It's actually a test of metacognition. The rubric explicitly states you are graded on reasoning quality, not on dashboard outcomes. Just let that sink in for a second. A student who loses all their resources and watches the preserve basically burn to the ground, but who demonstrates honest self-evaluation, recognizes their biases, and deeply explains their flawed process, that student actually outscores someone who randomly achieves strong ecological numbers but can't articulate why.
And these indicators of authentic learning mirror exactly what we need in the real world. Think about it. CEOs, policymakers, project managers, they deal with complex projects, delayed feedback, and immense pressure every single day. The ability to cite actual data, honestly acknowledge mistakes, catch your own biases in real time, and evolve your thinking, that isn't just a high school biology standard. It is literally the foundation of effective leadership.
The habitat basically uses a dying nature preserve to hold a mirror right up to our own minds. It asks us to look closely at our own reactions to uncertainty. When was the last time a cognitive bias rewrote your memory of a failure? When did you last throw good time or good money after bad just because you are emotionally attached to a project? So the crucial point is, the patience framework isn't just about restoring a forest. It's about how you navigate the incredibly complex, lag-filled ecosystem of your everyday life.